would be look at the graph. And I've blown it up to get it as big as I possibly can. And take a ruler, trying to keep it as straight as I possibly can. And knowing that this is the highest value, so T is going to be 365. It looks like that it's about 16,600. But if you told me it was 16,500, I would buy that. And if you told me it was 16,700, I would buy that, because it would be really easy to be off just a little bit. So the range actually goes from 0 to approximately 16,600. The domain goes from 0 to 365. And you write those as an interval. So your domain interval would be 0, 365. And actually, we would use square brackets because 366 isn't included, but 365 is, and day 0 was the very first day. And you would do the same thing on your range. You would start at 0, and it includes 0, so we use a square bracket, and go up to 16,600. And it would include that end value, but every value in between could possibly be a value for the Dow Jones Industrial.
But the notes was saying the range was 13,100 to 16,600.
Oh, yes. I'm sorry. I didn't know. I should have paid more attention. I did not notice this, and didn't notice that it was actually a break and didn't start at 13,000, and I should have. That's my bad. So it's actually not from there. It is from 13,000 to 1660. Because it didn't start at 0, well, it's not 13,000 either. It's probably about 13,100. I don't know, it's probably more than 100, maybe 200, 300. So we'll say about 13,200, because all I can tell for sure is that it starts here. And I know that that's, if this is 13,000 and that's 14,000, that's not 13.5 thousand, that's more like about a third of the way. So I'd say 13,200, 13,300, something like that. And again, I couldn't fuss at you if you got numbers close to this and say, no, you're wrong, because if we're using this little bitty graph to estimate, that's kind of judgment on our parts. So there's the bigger graph. But like it says, is it a linear function? No. This graph is not a straight line. You could probably use a linear function as a very, very rough approximation, but it would be very rough and it wouldn't be very dependable. And this one does say 13,100, and I think the reason it does, if I'm looking at my graph and thinking that that starts there, but looking at the PowerPoint, it does look like it starts right here. Because there's blue right there. It went from day 0, it went up to about 13,300. And about 16.6 does look about right, but like I said, you could be off on that a little bit. Now, I don't care if you write it this way. I much prefer that you just give me the beginning and the end of the interval, because that's easier to write. This is a whole lot of extra stuff, and people in variable invariably wind up getting their equal to or less than signs going the wrong way. So I like the interval notation. I think it's a little easier for you to remember how to do it. So the next one says estimate f of 14. Well, my best guess of where 14 is there, and I actually did this on the computer, it was kind of tricky, but I looked and I said, well, you know, exactly halfway between 32 and 0 would be about 16, and 14 would be a little less than that. So that's probably pretty close to where it is. So it looked to me like it was about 13,500, because it looked like it was pretty much in the middle. And then it says to solve the equation f of t equals 14,250. That means what value of t will give you the Dow Jones Industrial being $14,250. Well, that means I need to go about a quarter of the way between 14,000 and 15,000, because halfway would be 14,500. And then halfway from there to 14,000 would be $14,250. So you would start here, go across to the Dow Jones, and then try to drop down from there and decide about what day that was. And it appears to be about day 64, but there again, if you were to tell me that it was day 63 or day 65 or 66, I really couldn't fuss at you, because you don't have a really good way to see exactly what that day is, because this goes from 60 to 91. That's 30 days in there. And I can't tell if that's exactly 64 days or if it's exactly 65 days. I just have to come up with the best guess that I can. A lot of these are estimates, because when you've got a graph, all you can do is estimate using the graph. Now, if they had given us this table, on the other hand, and this is not a complete table, this is just for the first week. If they had just given us this table, then we could answer some questions pretty clearly. It says in the table that f of 0 is equal to f of 1, because when the day started at time 0, the actual values didn't change at the end of the day. It stayed at that point all day long. There was no change. But in day 2, it actually rose about 841 from day 1 to day 2. And you notice that it continued to rise in some places, but in other places it still remains pretty constant. So from day 0 to day 1, we kept the same value. In day 2, it rose a little bit. Day 3, it dropped down a little bit. Then day 4, it dropped down more, and it stayed there until day 7, and it dropped again. Now, the reason that it stayed the same from 0 to 1 is because the stock market's closed on New Year's Day. So it isn't going to change from New Year's Day to January 2nd. So the point to that is that for each T, there is one Dow Jones Industrial, but for several different values of T, we can keep the same Dow Jones average. And that doesn't violate it being a function. So with that idea, remembering that for each X there can be only one Y, we don't care how many partners Y's got, each X can only have one Y partner. It says, which one of the following, these two things are functions? Well, 16 only goes to 60. But 28 goes to 27 and to 19. So if it's the domain, the X value, it has two different range values. That's a violation of the function. It's okay that both 7 and 9 go to 12 and that both 28 and 43 go to 19. What's not okay is that 28 has two corresponding partners in the range. That is not a function. Now looking at the table, here x is 1 and y is 3. Then x comes along and it's 1 again and it changes partners. It says, well, no, I'm going to be with -3 by now. So that doesn't work. You're not allowed for x to have two different corresponding y values. It's all right that, for example, if I were to have 5 and 5 going to the same y value or two different y values, that would be all right. This one definitely is a problem because 1 is going to 3 and to -3, 2 is going to 5 and to -5, and 3 is going to 8 and to -8. So all of those have two partners. That's not allowed. Now this one's a little harder to think about. What about the x squared key on a calculator? If you punch in a number on your calculator, you square a number, are there two different possible answers? If you square it, not square root it now, be careful. If you square it, what's the square of 3? Now, it can't be anything else, right? What's the square of -5? What's the square of -5? 25. Okay? Now, -5 is 25 and +5 squared is 25. That's okay. That's two different inputs that you square. So the squaring operation always gives you a unique answer. That's the idea, is that if you pick out a number, there has to be only one possible unique answer when you plug that into whatever the function does.
So that is yes.
That one is a yes. This one is a no. That one's a yes. This one is a no. And the reason it's a no, take careful, put a circle around that part. The reason this is a no is because of these two branches right here. So the Dow Jones is a function, and the fact that this goes with both of these is not a problem, because for every individual day it has its own output value. Even though this same output was kept for days 4, 5, and 6, it's still a function. And the example we just looked at, the reason this is not a function is that. The x squared key, 1 squared is 1, 3 squared is 9, -5 squared is 25, +5 squared, still 25, but 25 is okay, it's the output. And it's the output of two different inputs. And that's okay. And then for this table, 1 is the same input, but it's going to two different outputs. 2 is the same input, or x, and it's going to two different outputs. 3 is the same input, but it has two different partners. So this is not a function. Where this was a function. So we've got some more examples. I think I'm just gonna move these over here so I can move them off more easily. So there's the examples we have so far. And then example D says the set of ordered pairs with the first elements are mothers and the second elements are their children.
Yes.
Yes, that's a function. Are you sure?
Yes.
Can a mother have more than one
Yeah,
child?
a mother can have more than one child, yeah, but where each thing is set of ordered pairs with birth of someone's children, depending on their birth mothers.
This means this
children
is,
cannot have
okay,
multiple mothers.
the mothers are X, okay? And for each X, can each mother have multiple values of children? And yes, one mother can be the mother of more than one child. That is possible. But that means then that X is corresponding to Sam and Susan and Billy. Too many branches going off X. So no, this is not a function. Because remember, the first element is the X, and that's the mother, and the mother's having lots of different children. And just like here, this is the mother, and these are her two children. Okay? Now, when we reverse that, the first elements are the children, and the second elements are their birth mothers. And it's important to notice that it's restricted it to the birth mother, because two mothers cannot give birth to the same child. Okay? So how many birth mothers does a child have? Just one. So this is a function. This is, it's actually, if you think about it, not the number examples, but this kind of examples actually gets you to thinking about what the function is better. It gets you the idea of the relationship. Let's suppose that I've got two trains. Let me just flip this over on the back. I've got train A, and I've got train B.
What's the difference between the second and first elements?
I think maybe it'll become clear with this, okay? Train A has routes every day of the week, Monday being day 1, Tuesday's day 2, Wednesday's day 3, Thursday's day 4, and Friday's day 5, Saturday's day 6, and it doesn't run on Sunday. Same thing with train B. Can train A go to both Boston and Los Angeles?
No.
And the answer is no. Okay? Train B can go on day 1 to let's say Cambridge. If I'd learned to spell. So all of these are Cambridge. Is this function? Train B's job is to go to Cambridge. It doesn't have to go anywhere else. Now, train A, if it's going to be a function, might go to Boston. And then the next day it might go to Chicago. And the next day it might go back to Boston again. And then it might go to DC. And then it might go to Atlantic City. And then it might go back to Boston again. So just like train B, it can go to the same city on multiple days, but it has to go to a different city every day. Or at least go to the same city every day. It is not allowed to go to 2 different cities on the same day. Okay? That would cause it not to be a function.
But on, let's say, day 7 and 8, it can go to Los Angeles on those 2 different days, right?
Yes. But it can only go to 1 city each day. And the reason I picked Los Angeles is because, you know, if you're going to Boston and then go to Los Angeles, you're not going to make it in a day. I don't care if you are trying.
Yeah, unless you're an airplane.
Now, an airplane, you could probably do that. Okay? Which is why I chose trains. Another way to think of it, and this is because I want you to understand what a function is. Which is those 2 food shops as a function. You're allowed to pick 2 things off the menu for a snack. 1 drink, 1 food. Which one is a function, partially? You think B is a function? Neither.
Is it
Okay.
one person? Is
It-
it one person or?
One person goes in and orders 1 drink and 1 food item to go with it. So the person is choosing the drink. They don't get to choose the food that goes with it. There's predetermined choices. Okay, because that's what a function does, is it gives you predetermined outcomes. Once you choose.
The first one is a function.
The first one is a function, because if I go in and order water, what are they gonna give me? If I go in and order a soda, what are they gonna give me? What if I go into shop B and I order water?
get two waters for some.
Yeah. If I go in and order water, I might get pretzels, and then the next person comes in and orders water, might get candy. Now, the rest of them, you know, tea goes with pie, coffee goes with cake, soda goes with pretzels, you know, those are one-to-one. But water is not one-to-one output, okay? So you have to think about, you know, what is the choice, and then once you've chosen, what are you guaranteed to have happen? That makes it a function. If you make one choice and there's two different possibilities for what happens, then that's not a function. And then I think I actually put a different one in the PowerPoint, so I'm going to go back to that for a second. I'm going to skip over those. I must not have put it in this one because one of my favorite ones is, let's suppose you have a jam making machine. People make jam all the time. Let's just suppose that somebody brilliant came up with a machine where you could actually just drop the fruit and the sugar and all that stuff in, and the main thing is the fruit. These other things are in there, but they're kind of part of the machine. The main thing that you're going to drop in is going to be the fruit. This is a jam making machine. So I drop in the fruit and it squirts out the jam into my jars, and I can seal them up and have them all winter long go on my biscuits and toast, right? Can I put in strawberries and get peach jam? If I put in strawberries, what am I going to get? Strawberry jam. If I put in apples, what am I going to get? You get apple jam. If I put in blueberries, I get blueberry jam. So this machine is a function machine. Once you drop something into it, it only comes out with one thing. Okay? So I don't want, the reason I'm giving you all these kind of odd sounding examples is because I don't want you to tell me what far too many students can parrot and yet don't understand what the point is. If I were to ask you which one of these is a function, is graph A a function? How do you know it's a function? What tells you that graph A is a function? Hmm? Okay. Yeah, everybody has seen this before because you had algebra somewhere before you got here. But here's the thing. The answer I usually would get about this is, well, if I draw a line on this function, it only crosses it once. So that makes it a function. Well, that sort of is true. But what makes it true, the reason it's called the vertical line test, because it can't be a horizontal line, it has to be a vertical line. If the vertical line drawn on it touches it in one and only one place, what that's actually telling you is that for any x value, like this one, you can get only one y value. So for this x value, I get that y value. For this x value, I get that y value. So a vertical line test only works because it shows you that for each x value on that function, there is one and only one y value. So if I were to ask you to explain why this is or isn't a function, you can't just tell me because the vertical line test says so. You have to tell me how you know the vertical line tells you that's not a function, or it is a function. So this first one is a function. This second one is not, because the second one shows you that for the x value 3, I get 2 different y values. For the x value 4, it is possible for 4 to be partnered with 2, but it is also possible for 4 to be partnered with -2. So this one is not a function. And the other reason I don't want you just to say something about that the line test tells me, this is a horizontal line. And it is a function. For 8, the y value is 7. For -8, the y value is 7. For -2, the y value is 7. For 6, the y value is 7. So its inputs all have the same output. Its x's all have the same y's. But it's still a function because each x has a y that is just for that x. The fact that somebody else has that same thing doesn't matter. All of them have their own y value. It just happens to be the same one. So this one is a function. And then the last one that you have in the PowerPoint, it says, is this a function? And yes, this is a function. If I put in -1, I come out with 3. And I don't get anything else. If I put in 0, I come out with 2. And I can't get anything else. If I put in 4, I'm going to come out with 1. I can't get anything else. So that's the reason that these are functions. Now, we're going to have to make an agreement on what this thing called domain is. And the math example that's given here is, unless otherwise stated, assume the domain of all functions defined by an equation is the largest subset of real numbers that are meaningful replacements for the independent variable. That's nice. What does that mean? So here's the easier to remember. There's two important commandments in algebra and in all of mathematics. They always have been true. They always will be true. And you know what they are. Thou shalt not divide by 0. You cannot have 0 in the denominator of an equation. That value 0 resulting in the denominator is a problem, so you can't divide by 0. And the second one is you cannot take even, which is square roots and fourth roots, of negative numbers, because there are no two twin numbers that have the same sign, twin numbers, that are going to give you a negative answer. And so my example here says, suppose that you have y equals -4x over 2x minus 3. Any real number can be used for x in this equation except what? No, I can actually use 0. Be careful. What I can't do is I cannot have that quantity to be 0. When would 2x minus 3 be equal to 0? How could you figure that out? Can you solve that equation? You move the 3 on both sides and divide it by 2. So x cannot be 3/2. Okay? So any real number can be used in this function. Anything in the world that I want it to, except 3/2, because that makes the denominator equal to 0. So if I ask you to find me the domain of this function, the domain of this function in words, all real numbers except 3/2. Can't have 3/2 or 1.5. Means the same thing. Okay? Now, that's a lot to have to write down. And for those of us that are lazy people, the way that we would write it is we would say any number from -infinity to +infinity except 3/2. And that's the way you would write it in math symbols. So the domain for f of x equals x squared, am I ever going to divide by 0? When you square something, are you ever dividing? No. Am I taking a square root or a fourth root? No. I'm squaring that number. So I can put any number in there that I want to. So the domain here is all real numbers. Or more simply, -infinity to infinity. And that means that if I can put in anything in the world, I can get out anything in the world. If I put in -2, I'm going to get 4. If I put in +2, I'm going to get 4. If I put in -10,000, I'll get whatever -10,000 is squared. If I put in 1/2, I'll get 1/4. So I can put in anything I want to, and that means that both the domain and range are all real numbers. There's no restrictions on what I can put in and no restrictions on what comes out. Now if I change that around a little bit and I say y equals x squared, but the domain is specified as -2, -1, 0, 1, and 2. Okay, this is the whole domain. It is these individual numbers. And if I put in -2 and squared, I'm going to get 4. If I put in -1 and squared, I'm going to get 1. If I put in 0 and squared, I'm going to get 0. Now if I square 1 again, +1, I still get 1. And if I square 2, I get +4. So actually, with this domain restriction, this is the range.
So when plugging it in, you don't have to put the 1 and 4 in, correct?
Right. Well, as soon as you realize they're going to give you the same output.
Okay.
then you don't have to list them twice. Now, if you listed them twice, I don't think I would fuss at you, because I just, these are just really kind of picky things.
I know, like, my math lab, it wouldn't let me list
Yeah,
them
it
twice.
won't let you list them twice in my math lab. And now you understand, I think, why. So here we've got y equals the square root of 6 minus x. What kind of numbers can we not do that to? Negative numbers. So if it's no negatives, can we put 0 under there? Yeah, square root of 0 is 0. So the numbers we have to be positive or 0. So in other words, 6 minus x has to be equal to or greater than 0. It can't be negative.
Is 0 through positive?
Hmm?
0 through positive infinity?
Well, actually, what makes this negative would be if x were equal to 6.
6, yeah, so that's
So if it was 7, no. If it was 8, no. 9, no, because when we subtract a bigger number from 6, we get negative numbers. So what that means is that x has to actually be equal to or less than 6, which means it goes from negative infinity up to and including 6. So this infinity always gets a parenthesis, but this gets square brackets because it can be equal to 6. So you have to look at it and you have to really kind of think about these. I'm not going to make you learn to solve inequalities all over again. If you look at that, 6 makes it equal to 0. Anything bigger than 6 is going to make it negative, but anything smaller than 6 is going to work. Like if I put in negative 6, 6 minus negative 6 is 12. 12 is okay. And it's going to be the same thing here. 2x squared plus 5x minus 12 has to be equal to or greater than 0. Has to be. Now, you can factor that if you want to. But quadratic formula, you will have quadratic formula on your test so that you can use it. Quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. That's always going to work if you're trying to solve a quadratic equation. And in this case, a is 2, b is 5, and c is negative 12. So the opposite of 5 is negative 5, plus or minus the square root of 5 squared minus 4 times 2 times negative 12. And that's all over 2 times 2. So that's negative 5 plus or minus the square root of 25. Let's see, 2 times 12 is 24, and 24 times 4 is 96, I think. Yeah. And it's positive 96 because this is negative times negative. So if I add 25 and 96, That's 121. And the square root of 121 is 11. So negative 5 plus 11 is 6 over 4, or 3 over 2, or 1.5, whichever one of those you want. And the negative 5 minus 11 is negative 16 over 4, which is negative 4. So it would be equal to when it's at 1.5 or negative 4. So my question is, should it be the numbers between those two that I'm allowed to use, or is it the numbers that are less than 1.5, less than negative 4 and greater than 1.5? And the way that I would check it out is I would say, okay, what happens if I put in 0? And that would be negative 12. So if negative 12 is the result, if I put in 0, 0 is between these two numbers, then negative 12 is certainly not equal to or greater than 0. So it's all real numbers except numbers between negative 4 and 1.5. And that means all numbers in between there, okay? So we'll pick up there the next time, and I will try to get some more stuff loaded into Shelby for the rest of the chapters I'm still revising. And I'll probably go ahead and give you a study guide for the final next class period.
Shift that a little bit. Yeah.
That better? I think everybody else is packing up. I'll just bring that to you.